Going live. All right. And we're live. So, provide a written proof for each. Be sure to state what is given. Conclude with what you are being asked to prove, and provide justification for your claims. All right, so they give you that PQ and RS are the same. I'm going to take out my pen, and I'm going to mark that on my diagram. So here's PQ, and there's RS. Hey, look, they're the same, and they even look the same. How convenient, Mr. Mac. Sometimes I don't make them look the same, even if they are. Because we all know that half you guys are just BSing your way through this, and you're just marking the stuff that looks like it is the same, instead of actually proving it is. What are we going to prove, speaking of which? We're going to prove that PR is congruent to QS. Well, what is PR and QS? I ask you. You're yawning in class, Chloe. Please. I don't have much, Chloe. That's PR. And QS. That's all. Let's not use pink. Let's not use pink. That just be silly. QS is this guy. So if you didn't see it, hopefully you see it now. And they have some overlap, right? QR is their overlap. Interesting. Are these segments or angles? Segments. What postulate do we have to deal with that deals with segments? Segment addition postulate. And what does segment addition postulate say? Somebody give me their summary of it. No idea? Yeah, go ahead.
The segments add up to the whole.
Yeah, right? The individual pieces add up to the whole dumb thing. So like PQ plus QR will add up to PR, right? And QR plus RS will add up to QS. And all those guys will add up to PS, right? So, okay. First of all, let's write down what we're given. We're given that PQ is equal to RS. So let's write that. Given PQ equals RS. Okay. So what other information can we pull out of this diagram? Because we are given this diagram. That is something we're given. Well, we can pull out segment addition postulate, right? Let's start writing stuff down. We want to know what PR and QS are, right? We want to get them in the same room together. We don't need to prove that they're equal. I mean, we do. But like, if they are equal, that should happen naturally. The way I describe this is that if you want two people that should be together, right, to get together, first get them in the same room. Don't try to, matchmaker beforehand, right? If they have something in common, if they are really meant to be together, if you put them in the same room, the math will take care of the rest. Aw. Right? It will. So all we got to do is get them in the same equation. That's it. I don't care if it's PR plus 7 equals QS, right? I mean, that would be bad because then they wouldn't be equal by definition. But, like, we just got to get them in the same equation, right? And right now we have PQ and RS. So we need to change that somehow into a PR and a QS. So what I'm going to do is I'm going to think about, well, what is PR? Well, PR is just PQ plus QR, right? So let's write that. So PR, I'll do in red, equals PQ, that's this guy, plus QR. I don't know what I'm doing. I'm not a real math teacher, right? I'm just writing stuff down. If you know it, write it down. Might be helpful, right? So we define PR, which is the green part. I'm mixing up all my colors here. And then the purple part is QS, right? I'll be consistent and continue with red. We know that's going to equal what two segments added together? What? Yeah, Lainey. Oh, yes, I'm sorry. It is very tiny. So QS. What is that made up of? Jerkica. QR and RS. So I'm going to write RS first. I'm going to add QR. Don't laugh at her name. She's a good kid. And she drew that. That's going to be the thumbnail for the video. Like and subscribe. All right, so we know that. Now, the whole dumb thing we know is going to be everything added up, but like I don't care about PS. There's no PS here, right? Now, is this going to be enough to turn PQ and RS into PR and QS? What do we do? What do we do? What do we do? What do we do? Check it out. There's a PQ. There's a PQ. There's an RS. There's an RS. And we want to change PQ into PR, right? That's what it says. And we want to change RS into QS. Well, there's RS and QS together. There's PR and PQ together. They're in the same room. They have something in common. So we should be able to switch them out. Check it out. Here's what I'm going to do. I need to switch out PQ, right? So I need PQ equals a bunch of junk, and I can switch it out with that bunch of junk. Right now, I have an equation that has PR on its own. If I get PQ on its own, I'll have PQ equals a bunch of junk, right? And I'll take that bunch of junk and plug it in here. So I'm going to take this equation, equation number 1. I'm going to take equation number 1. I'm going to rewrite it. I'm going to rewrite it with PQ on its own equals. Now, how did I get this on its own? Well, here's PQ. What's bothering PQ, where it can't be on its own, is QR, right? So I need to subtract QR. Is everybody cool with that? I'm going to subtract QR from both sides. Yes, ma'am.
Why did you do PQ?
So I'm taking this first equation, and what I'm doing is I'm going to subtract that QR to the one side, and so I'm going to get PQ on its own. Okay? Now, I wrote PQ on the left side, which is probably very confusing to you. But what I'll get is PR minus the QR that I moved over, right, equals PQ. So when I write that, I'm just writing it left to right. Are you seeing that now? Okay, good, because that's not easy to see. Thanks for asking, Jenna. I knew that would be confusing for people. So that's all I did. And that's the subtraction property of equality, right? So we have sub t prop. And then before, how do we get equation 1 and equation 2 to begin with? What do we do there? What postulate? How do we get these two? Segment addition, right? SAP. Right, that's how we know those to be true. So I took equation 1 and I just did subtraction property. We got PQ on its own. So check it out. I know what PQ is now. It's PR minus QR. Okay? So I'm going to take that eventually and plug that in there. Does that make sense? Right? If I told you PQ is 5, couldn't you plug in 5 here? Well, I don't know that it's 5, but I do know it's PR minus QR, so I'm going to plug in PR minus QR here. But before I do that, I'm going to take equation 2 and do the same thing. So which thing am I going to try and get on its own for equation 2? RS, right? Because that's what I want to switch out. See how I wanted to switch out PQ? So I got PQ on its own. If I want to switch out RS, I need RS on its own. So I'm going to write RS on its own equals. Now, how do I get RS on its own for equation 2? What do I need to do? Subtract QR. So I've got QS minus the QR that I moved over. And that's also subtraction property. Now check it out. This is PQ, right? PQ is this stuff. So wherever I had PQ, I can switch it out for this stuff. Wherever I had RS, I can switch it out for this stuff. So instead of writing PQ equals RS, I can write PR minus QR equals QS minus QR. So I'm going to do that. So I've got PR. Letters are hard. PR minus QR equals QS minus QR. Again, how did I get that? I took this guy right here and I rewrote it. Instead of PQ, I'm going to write PR minus QR. That's this guy, right? And instead of RS, I'm going to write QS minus QR because RS is QS minus QR. That's how we read that, right? Equal signs mean is. RS is QS minus QR. So wherever I see RS, I can write QS minus QR. Now, why did I do that? Because I want to get something with PR and QS in an equation, right? And that's what I did. PR and QS are in the same equation. There's extra junk there, but at least half the battle's over, right? The job is to get them in the same room. That's all we're trying to do here. And if they really are meant to be together, then the math will take care of it. Do you see how we can make it so they're actually equal now? Right, we did substitution here, by the way, SUBS. That's what this was, SUBS property, subs prop. We switched stuff out, right? Do you see how we're going to make PR and QR on their own? Would they equal each other? Or, sorry, PR and QS, I should say. No? What happens if I add QR to both sides? If I move that QR over? They cancel, right? I add QR to a negative QR, they go away. So again, let me show you the steps. PR minus QR, and I'm going to add QR to both sides. So I'm going to do that. Let's do it in dark blue, since I've already used red. I'm going to add QR to both sides. So I'm moving that QR over. Okay? And what happens is that the minus QR that's already there is going to cancel with the QR I moved over, right? I did that by addition, right? Add prop. And so what I get left over is just this goes away, and I get PR equals, this goes away, QS. Swag box. We're done. So check it out. QS and PR. They have overlap, right? It was QR. See how they had the overlap? They shared that. So that's what ended up going away. Got me to my goal. So when you do this stuff, okay, it's very free floaty, it's very free form, it's just like all over the place, right? You don't know what you're doing. And neither do I. So I write down what I know. Step one is I realized, hey, look, we're dealing with segments. Let's try segment addition postulate. I know the things that I'm interested in, PR and QS, are comprised of multiple pieces, right? PR is the same thing as PQ plus QR, so I wrote that. QS is the same thing as QR plus RS, so I wrote that. My goal was to get PR and QS together, right? Well, there's a PR, there's a QS. How do I get them together? What do they share? QR. So I switch stuff out, and I get one equation that has a PR and a QS in it. The rest takes care of itself. So up to here is what you really need to be able to see. And here, I just wrote down because, like, hey, why not, right? So really what your job is to see this middle bit. Write down that they add up, right? I hope you guys can do that. It's going to take some getting used to that you know that, hey, I need to write down what I see and what I know because you guys aren't good at seeing stuff yet. But once you start seeing it, oh, look, these two pieces add up to the whole thing. These two pieces add up to the whole thing. Let's write that down, right? Your next step is to figure out what you need to get on your own. Well, I need to get PQ and RS on their own because that's what I want to be together, right? So I did that. After we do that, I can plug them into the original thing. PQ is this, so I plug that in there. RS is this, so I plug that in there. Okay? That's what we're doing. Let's take a look at number 2. I think you'll see number 2 a little bit better. Number 2, it says, given JK is congruent to KL. So I'm going to mark that. JK, this bit, is congruent to KL, this bit. Now I'm using colors, so I'm only going to use single tick marks. And you'll see why in a second. So JK and KL are congruent. HJ and GH are congruent. Well, here's HJ, and there's GH. And again, I'm using different colors, so I can just get away with the 1 tick mark. You probably have to do 2 tick marks, right? They didn't tell us that HG and KL are congruent, right? They just told us these guys and these guys are. So these guys could both be 3, those guys could both be 2, right? We don't know that these are the same. But behold, lo and behold, KL is also congruent to HJ. Well, here's KL, and here's HJ. So it turns out these guys are congruent, right? They're all congruent to each other. And that's what they want us to prove, that GH and JK are the same. So GH, just so we're aware, is this guy. And JK is this guy. So all of these guys are congruent. We just need to prove it for these last two. So again, we're going to write what they gave us. What they gave us was this. Given, and color helps, JK is congruent to KL. And you're like, oh, it's in the directions. Why should I write it down? Trust me, write it in color and it will help. They also gave us that HJ is congruent to GH. Lastly, they gave us KL and HJ are congruent. And again, our goal is to get GH and JK together. Just get them in the same equation. So I'm going to pick one of these, and I want to turn that guy into this. So I want to switch out the JK for a GH and the KL for a JK. Notice that I have GH down here. That's one of the things we want to get together, right? And JK right here. So I want to get those guys together. Right now they're not. How do we get them in the same room? What do they have in common? Well, this guy's KL and that guy's HJ. Not a lot there, right? But what do we know about what they have in common? What do we know about KL and HJ? They're equal. They're the same thing, right? Ah. Okay. So JK is congruent to KL. Another way of saying that is JK is congruent to HJ. Because HJ is KL. So we could write that where it's JK equals HJ. And what do we know about HJ? It's congruent to GH, right? So check it out. Here's what I'm going to do. Here's the plan. JK is congruent to KL, right? But I'm going to write that as JK is congruent to HJ because KL is HJ. They're the same thing. So now I've got these two together. And then I'm going to say, wait a minute. JK is congruent to HJ. Well, I know HJ is the same thing as GH. So instead of writing JK as HJ, I'm going to write JK as GH because they're the same dumb crap. And now I win. Okay? So here's how I'm going to do it. Start with this guy. This is given, right? I'm going to write it down here again just to be obnoxious. So we're not doing that. What are we doing? All right, so I start here. That's given. Just so we're clear. Now I'm going to switch out that KL for HJ. Why am I allowed to switch that out? Two reasons. One, there's a property that allows me to do it. And two, you're only allowed to switch things that are equal, right? Are KL and HJ equal? Are they? Yeah, they are. So that's cool. We can switch them. What allows us to switch them? What rule? What property? The switch out one. You had a bunch of them last week. Substitution. So we switched them out, right? KL for HJ. Because they are the same. Right? They are the same. Again, my goal is to get JK and GH together. We don't have an equation with them together yet. So now how do I get GH in there instead of HJ? What's my next step? Jerica. Yep. I'm going to substitute GH in for HJ. Am I allowed to do that? Two reasons that allow me to do it. One, HJ and GH have to be congruent. Are they the same? They are. We already have that, so we're good. So we are allowed to do that. We have shown that they are. It's given to us. And then the rule that allows us to do it is, once again, by substitution. Now, that's not exactly what we wanted, right? They wanted GH on the left side and JK on the right. It's the same thing, right? But we do need to flip them. What's the property that allows us to flip things? A equals B, therefore B equals A. It's not the reflexive property. Remember, that's A equals A. What's the one you're going to mix up all the time? Where you're allowed to flip them right and left. 5 equals 3 plus 2, 3 plus 2 equals 5. What? The what? Inverse is something you remember from last year. Yeah. Symmetric property, right? So I'm allowed to flip these. So I'm going to write GH on this side. Is congruent to JK on this side. And that's exactly what we wanted, right? So now that it's exactly the same, we're done. Symmetric property. Swag box. Okay. Do you feel better about that one than the last one? Not saying you feel good, but you feel better. Good. We're not done with that. Stay on that side, or at least stay here with me. I'm going to walk you through it again so you know what we did. Because it seems like a lot when we do it in slow motion, but it's not when you go back and see what we actually did. Okay? So I'm going to give you a couple seconds to catch up. I know you're frantically writing this stuff down. Honestly, I would just screenshot this stuff. Or not screenshot, but take a picture of this stuff. Like, you writing it and missing the show and the logic that's going on is going to be way more painful to your learning than not having this written down. In fact, it'd probably be better if you went back and wrote it down later, right? And kind of walked yourself through the logic. Plus, it's on YouTube. Even if you get a bad photo of it, you can just go on there. So check it out. I wrote down what was given to us, right? And I know that my goal is to get these two together in the same equation. So what I did next is I took one of those that already had something I wanted in it, right? I just picked this guy. And I said, I want to change this side. I want to keep this guy because he needs to stay. And I want to change that guy to GH. So how do I get there? Well, I can't just substitute it immediately, right? We don't have anything that says KL is GH. That'd be really convenient if it was, right? But I do know that KL is this, right? So let's switch that out. Did it. Well, what do I know about this guy? How do I change him to GH? I'm still not there yet. Well, notice I have something that says he's GH. So I can switch him out. And now I'm done. Okay? We're trying to find what we have in common. We get the people in the same room, and if they're really meant to be, if they really are the same, the math will take care of the rest. Just start putting people together, right? Matchmaker, matchmaker, make me a match. Find me a find. Catch me a catch. Here's the deal. I want you to take a look at these. These are not easy. We're going to talk about these some more tomorrow. We don't have a lot of time, though. Okay, so we're not going to do a warm-up tomorrow. We're just going to go straight into this stuff. If you want to try this at home, my advice to you would be, one, cross this out, because that's not what that's supposed to say. It's supposed to say angle 1 is congruent to angle 4. This is my little way to see if anybody tried this over the weekend. Not you guys, because you guys didn't get the homework, but the other kids did. And everyone's like, oh, yeah, we tried it, and, like, no one saw that. Or this. This is even worse. Going to number 5. It says A, B, and C are collinear. You see any A, B's, or C's on there? No, you don't see anything. How about now? No. Put an A here, put a B here, and put a C here. They're really not that important. It's just trying to tell you that, hey, those are lines, just in case you didn't know. And then D, B, F, because I skipped E, because I wanted to. E for idiot. Okay? Number 3, here's my hint to you. It says 1 and 2 are complementary. What do you know about complementary? What does that mean? What? Yeah, they add up to 90. So another way of writing that, that's what's given, right? I should know that 1 and 2 add up to 90, so I'd write that, right? Write what you know. 2 and 3 are complementary, so I'd write that 2 plus 3 equals 90. The measure of 2 and 3, right? Don't forget those M's. We're trying to get 1 and 3 in the same room, right? Well, 1 and 2 go together and make 90. 2 and 3 go together and make 90. What do those two equations have in common? What's the same thing in both equations? Angle 2, right? That's what they have in common. Right? We got to find that common ground to get these people together. So, when you write that, I would get angle 2 on its own and do some substitution, right? That's my advice. Give it a shot. If you want, go online and look at the video from yesterday from any of my other classes because they're a day ahead, and it'll help you out with this stuff. I want you to go home and give this a shot. I know most of you guys aren't going to, okay? But you gotta do this, okay? Proofs are really difficult, and you're only gonna get better at them if you try it on your own and figure out where you're stuck instead of coming in and saying, okay, let's learn it all now, right? Figure out where you get stuck. Use the videos as a guide. It's almost a good thing you guys are a day behind, right? Like and subscribe, ring that bell, leave a comment. We're almost at 50 subscribers, which it's too late to put my dog down. Sorry. We didn't reach the stretch goal. We'll have to find a new stretch goal. For number 4, it says supplementary, right? What does that mean?
180.
They add up to 180, right? So write that down. We've got 1 and 2 together and 3 and 4 together. Ah, darn, they have nothing in common. Oh, but we have this, don't we? We know 1 and 4 are the same. That's going to be the thing that links those two together so we can get 2 and 3 together. Again, kind of make a plan of what you're doing here, right? Find out what they have in common. Oh, man, neither of those equations have anything in common. We have a 1 and a 2 there and a 3 and a 4 there. But look, that piece of information is essential. It connects this guy to that guy. That way we get these two together. Okay? It's a friend of a friend. Number 5. Prove that 1 and angle 3 are congruent. Well, vertical angles, right? Don't use vertical angle theorem. Too quick. We're not ready for that. Here's what I would do. Remember how we proved vertical angles a long time ago? Those are a linear pair. Those are a linear pair. They share angle 2. Check it out. For your health. See you tomorrow. Noah. Go away.
It's funny that you keep calling me Jerkica because that's like whenever little kids stole my name, I'm like, that does not say Jerkica, and it always says Jerkica.
It's funny though?
Yes.
Okay, good. Because I thought it was
I'm gonna sign this Jerkica.
Please do.
It's spelled